Hello, my dear students. Welcome back to the lecture. So here we'll start with the this particular panel now. Okay, we have to find the BBS for this particular panel. Again, it's a one-way slab. So it's very simple now. So I written one-way slab and I'll paste it here so that you can take it as a reference and try to do the calculation. So again, we already done this because it is 5 meter and 7 meter. So already we had done similar problem. So I'll just go in a flow now. Yeah. So this cutting length, whatever I had explained you for one-way slab, no, this one earlier case. So it's the same is here also. Hmm. You're getting the same answer also. See, 83. Okay, anyhow, the spacing was different in that case. Here it is 150. No problem. See, yeah. So this is 3955. You know how it has come. So 230 minus cover. This is 5000 minus the crank length, which is 1250. If you do, this is 3955. So this will be 42. Crank length 0.2 into h, and this is 1455. So crank is 1250 plus 230 minus 1 cover I have to do. Okay. Yeah. Now few people may think, sir, from here the bar has ended here. Again, you're starting from here. Here you don't have to deduct the cover exactly. But again, we cannot go to that level of understanding. So that is why what we do, we consider each as a single panel, and we consider that it is discontinuous edge here, discontinuous edge here. We're leaving a cover from both the side. But practically, this is a continuous. Your bar will come like this, take a crank, it will go like this. So that is why I told you doing a BBS for a continuous slab will be a difficult task. It's not that easy, and your project will become complicated. So that is why you break it down as a single panel and do it. So 90 to 95% you are getting the correct answer. Okay. Hmm. This is 1455. So main bar along the shorter span 110 dia. So here the spacing is 150, but I'm finding alternate crank. So 150 double is 300. So I put 300 here. So number of bar, I'll take 7000 divided by spacing 300 plus 1 I have done. So I'll get 25 number of bar. Cutting length, you add everything, add all the three, and minus the bend deduction minus 2 into D. So it'll give you 5432, 5.432. Total cutting length will be 5.432 into 25 into number of member is 1. So total weight will be 135.8 multiplied by 0.617. This will be 83.78 kg. Okay. Now this bar will go like this. So 25 number of such bar will come. Next bar will come like this. Give a crank and take it here. So this is 1455. Same thing here. 42 and 42. This is 3955. This is also 3955. I've written main bar along shorter span. You can write crank 1 and write crank 2. Okay, fine. Again, number of member is 1. Dia is 10. Spacing is 300. Coming to the number of bar. So again, same thing. 7000 divided by 300. But this time we'll not do plus 1 here because already plus 1 I've done it here. So 5432, 5.432. Cutting length remains the same. Okay. So this is 5.432 multiplied by 24 into 1. This will be 130.368, and 130.368 multiplied by 0.617. This will give me 80.4371 kg of a steel will be, you will be getting it. Okay, fine. So this is alternate crank 1, crank 2. Now come to, since it's a one-way slab, so next bar what we have is the straight bar, that is a distribution steel. So again the cutting length will be 230 minus cover plus this is 7000 plus 230 minus cover. Same thing I have done. 7410 is a cutting length, so it's written distribution steel along the longer span. Number of member is 1. See, this time the dia they have given is 8 mm, so I written 8 mm. Spacing is 150, so I have written 150. Number of bar will be, take 5000. So 5000, this is that 5000 divided by 150 plus 1 you do. We get 35 number of bar. So cutting length is 7410, 7.41. So total cutting length will be 7.41 multiplied by 35 multiplied by 1 will be 259.35 running meter. So since it's a 8 mm bar, 259.35 multiplied by 0.395, this will be 102.44 kg of a steel is required. Okay. Now comes the crank distributor. So crank distributor, your crank is only this portion and this portion. So since it's a one-way slab, we'll be putting a crank distributor only this direction. Okay, your crank distributor will come only in this direction. Got it? So cutting length of your crank distributor and cutting length of your distribution steel will always be same. So same thing, I copied it here. So I've written crank distributor here. So crank distributor both side 1, it's again 8 mm bar, 150. Why? It is never mentioned, but whatever you are putting on the longer span, that is 8 at 150, same will your crank distributor. So 8 at 150. Now come to the number of member. So this will be L by 4. So 5000 divided by 4 will be 1250. So 1250 is the length where your crank distributor will come. Divide by spacing is 150. Plus 1 if I do, I'll get 10 bar on left side. Similar on both the side we are doing. So I'm multiplying it by 2. So 20 number of bar is required. So now 7.41 cutting length. So 7.41 into 20 into number of member. This will be 148.2, and 148.2 multiplied by 0.395. This will be 58.539 kg. Okay, fine. So crank distributor is done. Now last what is left is top extra bar on both the side. Hmm. So this will be a top extra on this side and similarly on this side. So what will be the cutting length of that? You Yeah, this is how you will put the top extra. This is your top extra. Okay, here one small changes are done. Not required. Will not make it confusion. So it is 1250 only. Yeah. So top extra will be how much? This is 5000. 5000 divided by 4. Okay. How much it is? 1250 plus 230 minus 25 I have done. Okay, fine. 1, 10. So now the spacing is 300 because your main reinforcement what you had provided was at this is 300. Since the alternate, but actually the main reinforcement is being put at 150 center to center. So that is why top distribution I'm putting at 300. Okay, fine. You're getting my point, no? Hmm. The number of extra bar will be round up. This length is 7000. This length is 7000 divided by 300 plus 1 I have done. Plus 1 I have done. So how much I'm getting? 50 number of bar is required. I always told you, whatever is your main bar, same will be a top distribution bar, top extra bar. See, your this crank was 25, this was 24. So 25 plus 24, 25 plus 24 is 49 number of bar will get. But here you are getting 50. So you know that how many main reinforcement will come, that much only top extra will come. But since we are rounding up the values and all, here sometime one extra you'll get, sometimes, not all the time. So in that case, you can come and directly you do -1 here, not an issue, you'll get the right answer. Okay. What you do that, you do -1 here. Okay, wait, getting 50. You do -1, let me see. Yeah, you get 49. Why I did -1? Because I know that my shorter span 25 plus 25 is 49 number of bar will come. So that much only my top extra will come. But here due to the calculation, it is showing 50. So I did -1 so that my calculation will not be a little over estimation. But if you don't do also, nothing will happen. If you see the difference. If I do -1, I'm getting 43.93989. Okay. And if I don't do that minus, you see what is the difference you are getting in the steel. You're getting 44.888. And the difference is hardly how much, you tell me? It's just 0.90. So that doesn't make any difference. But you should know what is correct and what is wrong. That is why I'm doing that. So I'll do -1. I'll make it a 49 number. So cutting length will be 1455 only. So this will be 1.455. So the total cutting length will be 1.455 multiplied by 49 into 1. This will be 71.295. So since it's a 10 diameter bar, 71.295 multiply by 0.617, this will be 43.989. Getting my point? Fine. So in this way, if you ask me what is the total reinforcement that will come in this one-way slab, I've counted, I've done the calculation. It will be roughly 160 kg of a steel is required. Why? Not 160, sorry. 369 kg of a steel is required because 8 mm you require 160 kg and 10 mm you require 208 kg. Okay, 208 kg. So both it will be 160 plus 208 is in one way slab roughly 370 kg of a steel is required. Got it? So in this way, the second panel also I have completed. Now in the same way, since I told you this length and this length are same, I mean, this is 5 meter, this is 7 meter, this is also 5 meter plus this is 7 meter. Similarly, this is also 5 meter plus this is a 7 meter. And all the three, you see the one-way slab, one-way slab, and one-way slab. 8 die at 150, 8 die, sorry, 10 die at 150, 10 die at 150, 10 die at 150, 8 at 150, 8 at 150, 8 at 150. Since everything is same, you don't have to do the calculation again. You, in the number of member, you just multiply this by 3, you get the total answer. If I put number of member 3 everywhere, you get the answer. Okay, so that is a smart work. Instead of doing it again another 2 times, but anyhow, I have done and kept it. But my answer is also same. I'll show you that also. If you see here, we got 369 kg. You see here, 370 kg you are getting. Okay, here also you see same thing you are getting. 381 kg. Okay, it's not actually 381 because here's one change I've done that I'll tell you what I've done. 369 you got, no? Here 370 you got, no problem, almost same you're getting. Slight here and there one value may come because that is because of this top extra. That value is, I have to do -1 here. I'll see. 369 you got here. This 50 is coming. This also 369 you got. This also 369 you got. And this by default 369 has coming, no, same thing. But I have done 3 times. But to do it in a smarter way, you can multiply it by 3 and you can get it done. Since I wanted to explain each of the BBS, that is why I've done this. Got it, no? Now I've explained you for this 4 panel. Can you not find for the other panels on your own? Can you not find for this? It's a one-way slab. It is mentioned here. It's shown one direction. Same thing you do. This will be a breadth and this will be a length. Now you assume your own values because in this drawing the values are not given. You assume your own value. Let us say this is 3 meter and assume this to be 6 meter and do the calculation. Can you don't do that? This is a two-way slab. So assume this to be 4 meter, assume this to be 6 meter and do the calculation. Okay, each panel you take it out separately, no problem. Each panel you take it out separately and follow the method what I've explained. Outer to outer -1 cover. I mean, outer to outer you take -1 cover from here, -1 cover from here too. Outer to outer you take -1 cover from here, -1 cover from here you do. You get proper answer. 90 to 95% whatever answer we are getting, same thing we are going to match it on the side also. Okay, that much amount of steel only will come. Understood, no? So in this way, the crank bar BBS has to be done. Got it? So this means it's a cutout. The meaning of this is cutout. That means you don't have slab. You don't do BBS for this. This means there is a cutout. Only in that roof level, your slab will come. But you try to do only for one single floor. That is enough. Rest all remains the same only. Got it? Okay. This is one way. This is two way. One way. One way. Whatever dimension you want, you assume and do that. Okay. And so that will be a better way of understanding the BBS. So I think most of the things I've explained you how it has to be done and all. Now the most interesting part is that here in this particular drawing, these people had given your top extra is L by 3, but I consider everywhere L by 4 for my easiness. Okay. Suppose if I want to take this L by 3, then my calculation will be little difficult. Not difficult, so much of changes I should have been doing. Okay. So not required, but since I'm explaining you how it has to be done, I hope this much understanding you have. But anyhow, let me put it in a better way. For example, my clear span was 5 meter, isn't it? This was 5 meter. But here, these people are telling that L will be from this center to this center. So in that case, your L won't be 5000 because the width of this beam. See, this is a beam width or let us say column. This also beam or column is telling center from this center to this center you have to take. So what will be your length? Let us say if this clear span is 5000, what will be a L? So L will be actually how much? This is 5000. If this is 230, let us say this is 230. Width of your beam or width of your column is 230. This is also 230. What will be L? You tell me. So this will be 5000 clear span plus I want this distance. I want the center of this center. If 230 is a width, half of that you take. Half of 230, 230, half of that is this is 115. 230 is complete, half of that is 115. So 5000 plus 115 plus 115 I'm supposed to do, right? 115 plus 115. So this will be 5230. So this is actually L. We used to take 5000, But according to this drawing, your L will be actually 5230. Getting my point? So now, based on that, you try to do L by 4. So this L by 4 also is telling you to take from the center only L by 4. Your top extra also is telling you to take from center. So can you tell me, if my L is 5230, what will be this L by 3 then? This L by 3. So this L by 3 will be how much? Simple. 5230 divide by 3 you do. Tell me how much it will be. You getting my point, no? It will be 1744. I'll take 5230 divided by. So this length, whatever crank top extra bar you are going to put, no, this top extra bar, whatever you are supposed to put from here to here, this will be 1744. Earlier case, what was happening? Earlier case, I was taking this as L by 4 and I was getting 1250, 1250. But that was 1250 I was taking from here to here. But according to this drawing, 1744 will be from here to here. Again, the small portion is left out, this one. So this will be 115 minus 1 cover you are supposed to do. Getting my point, no? So that is how you are supposed to do. So again, if I explain you this, then it will be too much tedious work for me. I mean, for me in the sense, since if you're understanding it for the first time, it will be difficult for you. That is the reason I made it very simple by saying that my crank length and my top extra are at L by 4 and L by 4, and in my drawing both are being given from the face. From the face it is L by 4, from the face it is L by 3, L by 4. But in this drawing it is given from the center to center. Based on that you can do center to center calculation. Okay, try to do that, but I hope at least basic understanding you have how it has to be done. Okay, in case you have doubt, in case if you're not able to understand, you can always WhatsApp me on this number +91 yeah 99537790. Just WhatsApp me on this number. In case if you are not able to understand what exactly is this. If you're able to understand, try to do one panel, try to do for this panel and see how much difference will come in your answers. Okay, take this as panel. You already know the clear span is 5000, this is 7000, and beam width is 230. L, instead of taking 5000, you take L from center to center, which will be 5230. Just now I have seen that 5230, and your calculations will be according to that. So L by 4 will be 5230 divided by 4. So your crank length will be that much from both the side. I'll do that. Crank length, if it is L by 2, 5230 divided by 4. So it will be 1307. So this crank length, whatever you had, no, this bar will come like this. This bar will come. Okay. This bar will come, get a crank like this, go like this, right? Right. So this crank length, we used to get 1250 according to our L by 4 calculation, which we were taking from the center. Now this now this crank length will be from here, from the center, from this center to this crank length is how much? 1307. Now it is 1307. Okay. And if you ask me what is the total cutting length of this, so it will be 1307 plus. See, already you're taken from center to center. This is from center to center, center to center. Okay, from center to center. So again, if this is 230, half of that is already taken care, 1115. Remaining is 115 minus 1 cover you are supposed to do, plus 115 minus cover. So this will be a cutting length now. 1307 plus 115 minus 25. So 1397. 1397 mm, this will be a cutting length. So earlier case, what used to happen when we were taking L by 4 from the face, it was 1250 plus 230 minus 25. What was the answer you were getting? 1250 plus 230 minus 25. We were getting 1455. 1455. That means indirectly, if you're going for L by 3, there is a difference in the steel. So this is 1397. This is 1455. That means here more steel is going. Obviously, the weight of the steel also will increase. Almost how much difference is coming? Almost 58 mm of a steel, extra 58 mm is going in L by 4 portion previously. But if you go according to this, there is a shortage of, not shortage, there is a saving of little steel. So, but again, we cannot decide which one we want. Whatever the structure consultant will give, based on that, we are supposed to do the BBS. Got it, no? I hope this much understanding I have given you. Rest, you are smart enough to do it on your own. Try to do this calculation, because I can take a lot of projects, and I mean I cannot take all the projects and explain you. But whatever difficulties you may face in your projects, that I have given you how it has to be done. Okay, okay, got it. So try to do that. That's how the entire calculation has to be done. I hope you have enjoyed the lectures up to here. Similarly, you see here, the last portion is a crank. Yeah, this one thing I'll tell you. This is a sunken portion. So this is sunken portion. Sunken portion means this much slab, whatever you have, this slab up to here, this slab will be at one level, whereas your sunken slab will be down. That means this slab level will be different. How much different? From this slab will be lowered by 300 mm. That means if this is the level of the slab, from this slab, it will be 300 mm down. So practically, if you ask me to show that, I'll show you practically how it looks. Yeah. So this is that sunken portion. See, this slab, they have given it up to here. So this is sunken portion. This is sunk by 300 mm. This is sunk by 300 mm. So from where did I get 300? It will be mentioned in the drawing. Sunk by 300 mm. So this is sunken. It's a toilet area. That is why. So that your plumbing pipe and all will come there. So this is sunken. So for this, you do a separate BBS. Same thing. It's a one-way slab. You know how it has to be done. You take a bar from here, give a crank. It will go like this. Similarly, from here, Similarly, from here, your bar will come and you will give a crank like this. It's a one-way slab. So the other side bar will be a distribution steel. So this will be a distribution steel. You know how to find all these things now, isn't it? It's very simple. So that is how practically this sunken slab portions are done. Getting my point now? And once you do the concreting, practically it will look like this. See, this is your floor level. This was your toilet area. And this depth, whatever you can see, this will be 300 mm difference. Later, your plumbing pipe or whatever, later your plumbing pipe will come here and you are going to keep the Indian commode and all. That is why we do that. Okay. And then you are going to lay, after that, once you then you are going to do the brick pad filling, or you are going to do the uh, lightweight bricks filling. And finally, once you put the tiles, from this level, there will be a difference of 50 mm, because this is a toilet portion. When you pour the water in the toilet area, it should not splash into the floor area. That is why this floor will be always like 50 mm down. When you put the tiles, it will be 50 mm down. Okay. But right now, it will be sunk by 300 portion, so that you can take your plumbing lines and all. Got it? So I hope most of the things I've done. I've explained you how it has to be done and all. That's how it is. So I've done it individually. So no problem. You do it individually, all the slab panel. In case if you find any difficulties, not able to understand, always you can get back to me. I'll be there to help you out. Okay. Yeah. So we'll see you back in the next lecture. Thank you.